Alright, we're back. We're ready to do the selenium replacement with a silicone. I mentioned that I didn't know the exact formula for resistance for these. I decided to Google it, and of course you always find answers on there. The first hit I had, and all I did was type in selenium rectifier to silicone, and I got this article, and it's a very lengthy, very detailed article about changing them by Rich Bonowski, W3HWJ Bonkowski, and he goes into advantages, disadvantages, goes into a huge amount of detail, and then he talks about which silicon diodes to use and the voltage ratings of them. He personally uses a 1N4007 rated 1000 volts. I happen to have those. I bought a pack of them a while back and have had them for a while, so that's what I'm using. And then he goes into adding resistance, as we talked about, and yes, there is a formula, but the basic idea is you want to drop, and that's all in the article, it's very long, very boring. You want to drop about 10% of your resistance. I'm trying to find where he said it. Sorry to be bouncing up and down. But he said you want to drop 10% of your resistance, and you want to use a fairly high wattage resistor. He recommends about 2 watts, although he's using a 5 in this particular picture. Yeah, here it is. Rule of thumb, size the resistor to drop 10 volts, and then there's the formula, and it comes out to about 200 ohms to drop 10 volts off of 170 volts, I think it was, something like that. And then he goes on to say the best thing to do is simply start with 100, which is what I was going to do anyway, and then try different values and see what kind of voltage you get out. And I think that's the most practical thing to do. I went searching for resistors. I have a whole assortment of half-watt resistors. They're a little low. I don't have any decent power resistors except these old 1950s, 1960s wire wounds. I have a whole bag of these things. They're actually only 1 watt. I would have thought they would have been higher rated, but they're quite substantial and hefty. And the only values I had that were even close are I have a 100 and I have a 300. I don't have a 200. If these aren't good for my voltage, then I'm going to simply take my half-watt resistors and put them in parallel, which will increase their wattage capacity. Doubles it, basically. Parallel, of course, drops your resistance, but we can figure that out easily enough to increase the wattage. So that's what I'll be doing. And there's our little diode that replaces that along with the resistor. And I've put in the terminal strip we're going to mount it on. I have the electrolytics mounted. I have verified all wiring off throughout this whole section. Replaced the 2 electrolytics that were in that can over there. And I have verified all the wiring coming off of this and going to the coils. I haven't tested a coil yet, though. That I will be doing, as I said, I think on the tripod, because I think I have something open. But what I'm going to do, set up the tripod, put these in. I'm going to put the 100 watt one in. I'm going to tack them all in with a little bit of solder. Throw the voltmeter on there, and on camera see what we have for voltages. And then we'll move forward from there. I'll be back. Okay, we're on the tripod. I've tacked in the 100 watt, 100 ohm resistor, and we're going to turn this puppy on and see where we're at. Power's on. Actually, I don't need the clip. I have the ground clip on the chassis. I'm going to use the probe. So we're on the other end. We're going to go on the AC end and see what, just verify our AC voltage first, which is considerably higher. Now, I did not connect the other end of this, and I'm thinking the circuit was probably loading it down, although that's surprising. My initial reading was 125.3, but again, I didn't connect the wire to the other end of this, so let me do that. Okay, we're back. I have the resistor of 100 ohms hooked in to the silicon diode, and we are going to check AC first to verify it. Oops, I turned it off. Yeah, that helps. Okay, pilot light's on, it's on. Here we go. AC is higher, it's 131. I originally had an AC of 125. Not sure why it's higher. Well, let's see what our DC is going to be now. This is with the 100 ohm resistor. 160. We had 147, so that's considerably higher. So that's too low of a resistance. We'll pop in the 300 ohm and see what we get. And I'll tack that in and be back. Now, keeping in mind too, 160 volts DC, but I have a higher voltage AC going in also. 130. I'm 5 volts higher. I was 147 with my DC, so I'm going to say I probably should be 157. Oh, actually, that's pretty close. If I think of it that way, 150, 140, 157 to 100. Yeah, that. Let's go back. AC 130, 131. I had 125. That's 6 volts higher. DC 160. I had 147. So that's 13 volts higher. That's close. But I'm going to pop in the 300 ohm and see what the difference is. I'll be back. Okay. Trying to get this closer. Hope you can see that. It's hard to get it to the right angle so the glare isn't there. Here we go. 300 ohms. And once again, we'll go with AC first. Power on. I unplugged it wisely because I was changing parts. Plugged in, power's on. AC first. 132. DC 155. That's a better drop. My original was 147 to 125. That's a 20 volt difference. Went up, so that's 155 from 130. That's about 20 volt difference. I mean, it give or take a few volts. That's closer than the, I'm going back to DC. So that's what we're going to go with. I'm going to put in this 300 ohm resistor in series at the end of that silicone diode to drop down our resistance to make our voltage 155, which is close to what it was originally. Why my voltage is higher right at this point, I'm not sure. I don't know if that's my electrical service difference. I mean, this AC voltage is coming through the transformer. Actually, let me see what my voltage is on the end of the wire, now that I think of it. That must be the negative side, 54. I am on AC, right? Yeah. 60, that can't be right. I'm checking both sides of the line that's supplying power to this thing. And, which, sorry, you can't see because of my hand. Alright, that's 4.5. That must be the neutral side. $54. Let's see if not turning the switch off doesn't make. How can that be 54 volts coming in through there? That's ridiculous. I guess, could I say it's being pulled down that much? I don't know. It's certainly not what's coming into my house. 54 volts. Back to this. This is out of the transformer. 133 volts. 132 volts. Well, that's a mystery to me. But anyway, we're dropping about 20 volts, or going up, I should say, about 20 volts from the AC to the DC. We have 132 volts on the AC. And we have 154. Oh, I know what 155. That, on the other side of the resistor, what do we have? That's a good question. 157. I'm only dropping 2 volts. 157. That's right on the end of the diode. On the other side of the resistor, 155. I'm only losing 2 volts across that resistor. That ain't much. Maybe I should go with a higher resistance value. 155. But I don't have a higher resistance other than my half-watt resistors that I have to put in parallel. 157, 158. I'm losing maybe 3 volts. 2.5 volts is all that resistor is dropping, the power. Now remember in the article I mentioned, they said you want to drop about 10 volts. But 300 ohms is fairly high. I mean, that's higher than what the gentleman who wrote the article recommended. He said about 200 is normal, and he said start at 100 and work your way up. And I got a 300 ohm resistor here. But you know what? I think I'm just going to put it in. Because I don't have another one. I don't want to parallel the smaller wattage resistors. I'd rather use this one. It's fairly robust. So even though I'm not getting a huge voltage drop there, this is hopefully going to be adequate. Thanks for watching. The next thing I'm going to do is, once I get that tacked in more permanently, is we're going to look at the coils. And actually, another thing I wanted to mention, I found a voltage table for this meter. It's only the voltage tables of the pins on the 2 tubes that are used in it, voltage and resistance, so that will be helpful if we have an error. And the other thing I'm going to do is power this up, and using my software-defined Afedri radio, which is a software-defined receiver, I'm going to send a signal to the receiver, not directly, but with it near the antenna output, and try to see what I'm getting as output from this thing. That'll be interesting to see. I think, in fact, that's what I'll do next, and we'll see what our output is and see what's if and which bands are not working. Because as I recall, I think there was one band that simply didn't function, and once I verify that it's not working, then we'll go back and we'll look at the coils and try to figure that out. That'll be the way that'll go. So the next thing to do is I'm going to stick it in the cabinet, get my software-defined radio going, and we'll see what this thing is putting out. as far as actual radio signals and frequencies. And thanks to Jim Lindenas for that tip. He's been aligning radios lately using an SDR receiver. It's kind of interesting to watch. I've never thought of doing that. And basically you're using it as a spectrum analyzer. It's pretty interesting, and it seems to be working for him. So, and I figured that would be a good way to just verify what's working in this thing and what's not. I'll be back with that. This is Alright, so we're set up to do our testing. I thought I would show you real quickly. I was questioning the voltage coming to my house. This is my voltage where I was plugged in, 117 to 118. Why that, I'm going to unplug this because I have to plug in the meter, the generator. Why it was 50 on that end of that plug, I don't know. I guess loading down to the circuit. That's one area I'm not real good at, is the real technical aspects of electronics and how the circuits work. But anyhow, this is the Afedri direct conversion software-defined radio. We have it hooked to my antenna at the moment, and I'm receiving AM. This is 810. Just to verify it's working, I'm running SDR console written by Simon, a guy in Switzerland. Awesome software. This guy wrote Ham Radio Deluxe as well. Sorry, I was running out of battery. I had to plug this thing in. It's got an old battery. Well, as you can hear, it's functioning on the A band. I plugged it in, I got it going while I was messing with the camera. A band is 160 to 550 kilohertz, and this little signal here, and you can watch it move, is our signal. Interestingly, it's pretty low amplitude, and I have it on the lowest attenuation. If I attenuate it more, of course it drops, and then I put it on high, then it drops even more. And then this is the coarse adjustment here. It drops down to nothing, and I can turn it way up. But it is working on that band, and it's 160 kilohertz. Well, 200 at the moment. So we're going to knock that up to, let's see, that goes up to 550. Well, you would do a radio alignment in the 455 range. So let's just do that. Make sure I'm getting that. There it is. That's what I'd be aligning a radio, an AM radio with, generally speaking. It's not the greatest signal. It's there, it works, but I have this thing on low attenuation, which means it's full blast, not being attenuated. I have the coarse attenuation up all the way. And this modulation gain, I have no idea what this is supposed to do. Oh, I guess it's changing the tone a little bit. Yeah, it is. That's the modulation gain. So that's the best I'm getting out of it on that, on 455, which is a common frequency to do a radio on. So let's go up to the next setting, which is B. And B goes from 550 up to 1800, so we'll drop, well, I should say not drop, but go up. We'll go up to 550, and we'll dial this back into that range. And here comes our signal. There we go. Again, it's there. It's not super strong, but it's there. As far as accuracy goes, let's see, that's on the 550. And I'm reading 556 on the radio. And it's hard to see that clear thing with the line. We're at 550. So that's not bad. My battery's dying again. I'm going to have to plug it back in and do the remaining 3 bands, but it is functioning in the first 2. Alright, we'll try to do a little more before I lose my battery. I flipped it to C, which is 1.9 up to 7.0, and we'll power it on. There it is, yep, right there. Good, that band's working. I'm going to do this quick because I don't want to lose my battery again. We're going to go to D, which is 7 to 8. 7 kilohertz. This would be like the ham band. Not that you would ever use this thing on these bands. There it is right there. Boom. Yeah, oh, that's much stronger there. Better signal for whatever reason. Stronger circuit. Okay, and then finally E is 27, which is like CB radio. Well, 29. Alright. Oh, there it is. Right. Beautiful. I think that's it. Oh, wait a minute. Is that not it? It's not moving. Isn't that weird? Oh, wait a minute. I just saw it. I don't know what that signal is, but that's not this. It's not the generator. Starts at 27. Oh, you know what? I'm at 26. Let's just go up to 28. Boy, that's noisy there. I don't know why. What that's all about. Oh, there it is. Here it is. And here we are. Okay, so all the bands are working. What I'm thinking is this low band of 160 to 550 was weaker than the other bands. Maybe I thought it wasn't working before. I don't know. But it's working. Everything's working. So I have a functional signal generator with new capacitors, and we're happy with that. And it was fun playing with the little SDR. So before my battery dies, this is Tom signing off, saying 73, and we have a new piece of test equipment that'll work for aligning radios you'll see in future videos in the shack. Thanks for watching. This is Tom.